So let us solve this problem. Now to find the direction cosines for this. So let us consider L, M, and N be the directional cosines of the line. Then L is equal to cos 90, okay, which is 0, and M is cos 135 degrees, which is cos of 90 plus 45, okay, so which is sine 45, and this is minus 1 by root 2, and n is cos 45 degrees. So cos 45 degrees is 1 by root 2. Okay. So therefore the direction cosines are 0, minus 1 by root 2, and 1 by root 2. Now let us solve this problem. Let us consider that the line makes an angle alpha with the coordinate um, axis. So which means L is equal to cos alpha, and M is cos alpha, and N is cos alpha. Okay. So we know that L square plus M square plus N square, which implies cos square alpha plus cos square alpha plus cos square alpha. Okay. So now, which is 3 cos square alpha, which is equal to 1. So cos square alpha is 1 by 3, or cos alpha will be plus or minus 1 by root 3. Okay. So therefore the direction cosines of the lines are plus or minus 1 by root 3, plus or minus 1 by root 3, and plus or minus 1 by root 3. So let us solve this problem. Now we have the direction ratios, which are minus 18, 12, and minus 4. Okay, these are the direction ratios. Okay, now the direction cosines will be that is L, which is minus 18 by square root of minus 18 whole square plus 12 square minus 4 whole square. Okay, so M will be 12 by square root of minus 18 whole square plus 12 square minus 4 square. Okay, and N, which is minus 4 by square root of minus 18 whole square plus 12 square, and this is minus 4 whole square. So which is minus 18 by 22 and 12 by 22 and minus 4 by 22, or this can be written as 9 by 11 minus 9 by 11, 6 by 11, and minus 2 by 11. So these are the directional cosines. So we got to show that these points are collinear. Okay. Now let us consider this as A, this as B, and this as C. Okay. Now, as we know that direction cosines can be found by x2 minus x1, y2 minus y1, and c2 minus z1. Okay, therefore the direction ratios um, of AB and BC will be minus 3, comma minus 5, comma minus 3, and 6, 10, and 6 respectively. And as we can see that AB and BC are proportional. Okay, so we get that AB is parallel to BC. So therefore the points are collinear. Now that here we have the vertices of the triangle, which are 3, 5, and minus 4. Yeah, and B, which is minus 1, 1, and 2, and C, which is minus 5, minus 5, and minus 2. Okay. Now the direction ratios of AB will be minus 4, comma minus 4, and 6. Okay. Um, we get square root of this is 16 plus 16 and 36, which is equal to root 68, which is 2 root 17, 2 root 17. 17. Okay. And yeah, so L will be minus 4 by this is square root of after simplifying it. Okay. Let me 2 root 17. Yeah. And M will be minus 4 by 2 root 17, and N will be 6 by 2 root 17, which is equal to minus 2 by root 17 M minus 2 by root 17 and N, which is 3 by root 17. Okay. So therefore these are the direction cosines of AB. Okay. Now similarly direction ratios of BC will be direction ratios of BC will be that is minus 4, minus 6, and minus 4 again. So L will be minus 4 by This is 2 root 17 m minus 6 by 2 root 17 n minus 4 by 2 root 17, which is equal to this is minus 2 by root 17 m minus 3 by root 17 and n minus 2 by root 17. Okay, so the direction cosines of BC are these. Okay, now the direction ratios of CA will be minus 8, minus 10, and 2. So L is minus 8 by 2 root 17. Sorry, and this will be 2 root 42. Yeah, and M will be minus 10 by 2 root 42. Yeah, and N will be 2 by 2 root 42. So on further simplifying, the direction cosines of CA will be minus 4 by root 42 and minus 5 by root 42 and 1 by root 42. Yeah, so that will be your answer. Please do subscribe.